Good morning, everyone. Today, your assignment is to do AMA like we learned yesterday. So if you look here, and if you look here, hold on. If we look here, we're looking at, hopefully you can see this, that today's assignment is not here because this is the wrong class. And digital electronics, no, you guys aren't digital electronics, you guys are engineering. Here we go. Classwork, and we go to today's assignment, and here it is right here. Find the AMA of your lever, your first class, second class, and third class lever. So let's start. So to do this, you'll need your lever, this thing here. And you'll need everything you need for it. And I want you guys to realize that to do AMA, we need two things. So let's do that right now. Let's find it. I have it here somewhere. No, I don't have it. Give me 1 second. There we go. Share screen. There it is. Okay, so this right here. So to do this, we'll need only two things. So it's not as much as you might think. So if we're going to find the AMA of a first class lever, let's say, we already know what the first class lever looks like. For us, it's the same on both sides, but we'll go ahead and we can put the weight anywhere. It doesn't really matter. I just record down where you're putting it though, I guess, but maybe we'll put it on the same side. So we're gonna have this big old bottle, right, of weight. And then we're gonna pull down with like that spring lever right here. We're gonna pull down this way and lift this. So our effort will be over here. Our resistance will be here. This is the big bottle of water. And that's all there is to it. So we only need two things. We need to know the force of the effort, how hard am I pulling? And I need to know the force of the resistance, how heavy is the weight? And let's just do both, and then we divide them and we're done. That's all there is to this assignment. So first we're gonna find this, the force of the weight. How much does that weight weigh? Well, to be honest, it doesn't have to be exactly whatever you want. So it does come with this like sticker thing right here. And I don't know if you guys put it on. So I think the only reason is it makes it easier to see. There's actually already numbers on the meter. So I'm talking about this thing here. So first things first is make sure that it moves. If it doesn't move, maybe it's locked or something. I don't know if you have to twist it, but it should move. Like, you pull harder and it moves further, right? Because it's pretty much just a spring scale. And then I'm going to see if I can get this sticker off. I have it right here. You know what? I'm going to do it without the sticker. So I can't even get this dumb sticker off right here. But you don't have to use this right here, this sticker. If you want to, slap it on the side right here, okay? In the end, we can use whatever it says here. I think it's like grams on one side right here. So grams, or I think ounces on the other side or something like that. It doesn't matter as long as we're measuring the same on one side as we do on the other. So let's go ahead and add some water to this. It tells you to add this until it gets to 1 Newton of weight. Well, I don't have the sticker for 1 Newton of weight, so I'm just going to add some water to it. And I'm probably just going to fill it to like the water line. It says water line right there. So I see water line on the side. So I'm filling it to what it says water line. I'm going to twist it around so you can see that. So this is water line right there. So I filled it to the water line. I don't know how much this is going to weigh, but we'll find out in just a minute. First thing first is cap my water bottle, because I learned the hard way that I'll spill it everywhere on my computer. Make sure you cap this really tight too. Your bottle, make sure you cap that really tight. And now it's pretty heavy. How heavy is it? Well, first off, before you measure, I don't know what you're measuring with. Whether it's a sticker, it doesn't matter. Make sure that there's a 0 here. Twist this. See how it goes up? This goes up. And if I twist this way, it goes down. So just calibrate it so it says 0. Okay? So just calibrate it so it says 0. Then we're going to go ahead and take this heavy water and we're going to pull it down like that. And now it's at the 5 ounces. So it's on 5 ounces right now. Okay? So we're at the 5 ounces. I can see it right here. It says 5 ounces. It's hard to see because it's clear. But for me, it says 5 ounces. So I already know what this weighs. It's 5 ounces. I could use the other side that says grams, but my eyes aren't good. So the ounces side seems easier. So first things first is that this force of resistance is equal to 5 ounces, okay? Now, how hard do I have to pull on the other side? Well, for that, we need to build it really quick. So I already have the one answer. I just need 2 answers here to get the real answer. So I'm gonna go ahead and stick this thing back on, and I put it here. So I'm just putting this through, and then they have this little wheel or gear thing that I'm gonna use to stick it on the other side so it doesn't fall off. There we go, I have my gear. Now, I'm gonna put this right here wherever I want to pull with the heavy weight. So I'm gonna go ahead and put the weight down, and boy, that thing really pulls down really hard here. Now I'm gonna pull down on this side and see how hard I have to pull to lift it. So for you, I would put this on a corner of a table or something. For me, I'm gonna try to put this in your view. And I'm going to pull, and then I'm going to measure. Trying to read what it says here. It looks like it says 6. So 6 ounces. So here we go. So what you want to do is pull it just enough like that and then try to read it as you're holding it still. So I read 6 ounces for my effort. That's how hard I'm pulling down, okay? So let's go back here. And we're gonna say that this is equal to 6 ounces of force right here. Now we have both forces. I know how heavy this side is and this side is. Remember that AMA is simply equal to the force of the resistance divided by the force of the effort. And so my resistance is 5 ounces. My effort is 6 ounces. And then I just do a little bit of math. Let's see if I have something here. I do have a calculator here somewhere. So I'm just going to use my calculator. The type of, by the way, the type of lever I just did is called a first class lever. So let me just do the math real quick. We just type in 5 divided by the 6, and we get 0.8333. So let me use my pen here, 83, like that. So that's the answer. You could also write it 0.83 to 1 ratio. You could write like that. So either way you could write it. You could just say that the actual mechanical advantage is 0.83, or you could say 0.83 to 1, whatever one you want. And all that means is that that it's actually harder to lift than the actual weight. So the weight's 5, and because we're less than 1, the answer is less than 1, that means I'm having to push a little harder, that's all. And this is a first class lever because there's a fulcrum, and the effort and the resistance are on opposite sides of the fulcrum. Okay, so next, to do your work, you would have to do a second class lever. And a second class lever, we have a fulcrum, and we put the weight right here. So right here is the resistance, and then we have to pull up with the effort. So this is the force of the effort, and this is the force of the resistance right here. And that's a second class lever. So you would just repeat this, and I'm not going to do all the math for you again because that's your job, but it would look something like this. You would have to like disconnect this is all. So this is the first class lever because we have a weight over here and we pull on the other side. The second class lever, we just kind of pop this wheel off, pull the pin out, and then move this, preferably to all the way to the end. It doesn't really matter where, but to the end is totally fine, to the last hole. And then we have to put the weight somewhere over here, anywhere, it doesn't matter where. I would record where you're putting it though. Say, okay, so here's the fulcrum right here, right where it balances from, and go, oh, there's 1 hole, 2, 3, 4, 5, 6, 7 holes, and then hang the weight there, which I'm going to do right now. I'm going to pull at the very end, so that's at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to pull 15 holes. That way I know later on if I want to calculate the IMA later on, I can. Right now for AMA, we just need the weights. I already know the weight of this water. I don't need to measure it again. It's 5 ounces. So that's done. I just want to know how hard I have to pull up to lift it. So if you look, it just kind of falls down, right? You know, I got to lift it over here. So I'm going to go to that 15th hole. I'm going to go here and I'm going to lift it up and see how much force. And here it looks like, oh, I'm on the wrong side now. Of course, let me flip this around so I can read it. I'm going to flip it to hook this side. There we go. So now I lift it and then read it. And I'm reading it's that first number right there. Just under 4. So I'm going to put 4. So I'm just reading 4. So now I'm pulling 4 to lift 5. I already know that the AMA is going to be greater than 1 because it's 5 ounces, but I'm only pulling with 4 ounces of force. So the AMA is going to be greater than 1, which means there's some good mechanical advantage there. That means I don't have to lift so hard to lift the weight. And you can kind of feel it anyway when you're doing it. Lastly, to do the third one. So what would that look like? So if we go back over here to the drawing, a third class lever looks like this. We put a fulcrum. So it looks exactly the same as this. I don't even need to change my thing. The only thing I do need to change is that I need to put a weight over here at the end. So I need to put a resistance here. And then I need to lift up from here. So this is the force of my effort, and this is the force of my resistance. So that's what we change. See, here, the fulcrum's at the end, and the resistance is in the middle, and I lift up on the end. This one I lift up in the middle, and the weight's on the end. And this one's going to be hard. Definitely the AMA is going to be less than 1 for sure. And it would look something like this. So pretty much the same. I don't need to rebuild this. I don't need to move anything. The only thing I need to move is this little pin where I put the weight. You know, the big resistance, the big water jug. And I'm going to put this here at the end. There we go. Now it's really heavy. Now it's really pulling on this plastic. And then I'm going to lift somewhere, and I would record where you're lifting it, like how many holes here and how many holes away was this, you know, so that you know. And I'm going to lift it from about right here. And now I'm getting like 12 ounces. So I have to pull with 12 ounces to lift that thing, to lift 5. So that's just the way it is. I know the AMA is going to be much less than 1 when I do that math. All we're doing is taking how heavy is this, like, you know, when I hook it, like how heavy is this? And then we're going to divide that by how hard do I have to pull to lift it? And that's it. We're just taking those two numbers and finding what the actual mechanical advantage is. Because if we're just measuring distances and dividing them, we're getting the ideal mechanical advantage, like what the mechanical advantage should be, but we don't know if it really is. And then this is what it really is, because I'm actually taking a real weight and pulling it up and measuring those two forces and dividing them and finding out what the actual mechanical advantage really is. And those two numbers are never exactly the same because of friction and stuff like that. So are there any questions?